Okay. Great. So your turn, please.
Yeah. Okay. My voice audible for you?
I think if you can turn to yourself, it is okay. Simply because
No.
advanced technology. It works.
My voice audible for you?
Well, for me, yes.
For others.
Anybody online, please.
Yes, sir.
Great. Thank you very much. Thank you very much, Manuel. You are most reliable and responsible. All other people, well, hope that they hear.
Yeah.
Please go ahead.
Please. Very good afternoon in Russia, as well as good evening from India. I don't know things. So today I want to talk about my whole research, my research in this is a lecture for simply that what I'm working in Indian groups. Okay, and the results available in publications ways. You can just check it out. You just read it in these papers, and if you have doubt questions, you can just write me. We can just make a more discussion. So, by the way, my name is Radhakrishnan Delhibabu. You can just type my Google. You can find my there's only name in the world. So usually you can just catch me very quickly. So I'm working on like different field, and we are going to present in mostly in AI based what kind of work. We are in touch with that. Okay, so my okay, what about yeah. So first of all, I thank Slovak because of I know Nicola. She was no maybe 6 years.
Something around
7 years.
7
years. Thanks for the invite. And then I know many people in Indianapolis. Thanks for it. And by the way, so I'm asking that what's the meaning in Kazan? So I just special thank with more than two people. One is Aslanov and Iskander, both working currently. I just invited from Kazan Federal University in Max department, like a mathematical center. They invite me, and I'm just coming for in Kazan more than 2013 December. That means 7 plus 8 years relation between Kazan Institute and Indianapolis things. Okay, so currently I'm visiting short duration in Max Center. Okay, so the thing is here currently I'm just giving a couple of things to discuss all my activities because of Nicola asking that show me all the what I am working on. Interesting because I know him only in belief fusion theory, but I'm working more on currently in India. So first of all, I introduce my teams, and second thing is I go for mostly application of AI. So basically, I'm just putting on application AI. First thing is machine learning with IoT. We gave two problems things. One for water body management problems, and second thing is like a too much problem for in machine learning perspective. And second thing is cognitive science, especially for EEG, how you're doing for EEG things to make automated. And second thing is how the brain function working on in meditations. And the third thing is maybe Nicola know that what is belief fusion and cognitive robotics. And the third thing is in the main agenda is security. That's very important for security things. The first thing is I'll go for how medical devices with using for blockchain, how do for security. And the next thing is how to predicting anonymity in networks. So again, this is all my students' work. I'll tell you all the details in things. Okay, so this is a thing. And finally, I close up this application for social things, so like for society for COVID, how actually happening in COVID for in current pandemic things, how to achieve in COVID things in AI based. Okay, this is a thing. Finally, I just close my remark for results and something else. So that's the thing. Okay, so I'll see. This is the thing. I'm just interacting. This is I'm just showing what what me and my students working. And if you could stop me, any doubt, questions, because this is a friendly, because of I see that currently 4+ some people here. Some people are sitting with me, or 2 people,
At least 2 people.
and online some more people. So you can stop me anytime, and then we can discuss whatever you like it. Okay. So I just go for small about my institutes, because my institute. His name is called VIT, Vellore Institute of Technology, southern part for VIT. I didn't put a map because you can type it VIT Vellore, you can find out that it's a pretty big institute, 4 different campus, Chennai, Vellore, and Amaravati, and Bhopal. So 4 different campus, and we have a very quite number of rankings, because I need to say that because of people first time know that so the VIT among top 10 private institute, #1 private institute in India, because of India is large institute, I can say more than 1,000 institutes, universities, but #1 institute in India, and ranking is especially QS ranking top 200 in Asia. So that's the one thing, and 7 subjects top among the top in QS ranking in all over the world. Okay, and you can say NRF ranking, again Indian ranking for 12 best institute in India. So the 12 best in India is come together, putting all central university, state university, everything is ISC put together, and especially for 12 best engineering institute also. And in a NAC ranking, the 3rd cycle we got 3.66, big rank, the #1 ranking in, could say that. Okay, and finally we got IOE. So that's a very important thing, is IOE, like a atomic body. So they give IOE institutes in currently in VIT also. So we can
A short question. Well, student enrollment. How many students do you have? Are they from a region, local region, or from India? And how do you have international? This short comment to make question more clear and more precise. I do believe, indeed do believe, that the major asset of our university is our students' body, because it is not only Kazan students' body, it is indeed, it incorporates students from all Russia and abroad. So I believe it is one of the assets.
Yeah, India, you can check with VIT, especially the Innopolis, already we had sent a mail to that our register and IOE office, like international office. So we are going to agreement, because of we have a quite number of international students, and then regional wise, because of mostly India is a big country, that we can get a lot of students from outside this India also, because there's a very quite number. Okay, you can say that I cannot say exact numbers because I didn't see that, but we have a quite number. And then especially computer science, we can say that like demanding field in India currently, because everyone want to informatic things to it. Okay. Yeah. Yeah, so I can say we have a group, that's our group, PhD group, like Ramesh, and I think Rajesh joined here. It's my student only, I guess. Rajesh joined, and then so the third, Sumi, but actually it discontinued my group, but she got a couple of good papers. That's why I put it, but it's dismissed. And last thing is Mohammed. He has some paralyzed things, but we didn't work much, but we start some problem. I don't know. Currently active 2 students, but 3rd students is quick, but she have good papers with me. That's why I put and he's my collaborator, project collaborator. First 2 people doctors. First one is Dr. Viti Prabhakaran. He's a neurologist CMC, because in Vellore, because currently I'm from Vellore. Like the Vellore VIT, Vellore is one more famous in medical things. So there's a CMC #1 private institute, private medical college in India. So he's a professor in working in neurology department. And second thing is Resens, because he's a neurosurgeon working in Amita Hospital. So I'll tell you what trust within these projects. I'll talk about it soon. And third thing is CC Rai. So he's a physics guy. So a retired professor in quantum mechanics. You can check with in India, if you check with quant. So he working on some cognitive perspective, because I started cognitive because of him. Okay, so that's the thing. Last two people from my institute, one from Vijay. So currently we are Vijay and Bala. We are working on some projects and submitting some good projects. So first two people, doctor. Middle is a professor, retired professor. Last two is my colleagues. Okay, but the like Vijay is physics department, and he did PhD in France. We have plenty of good experience, and Bala have same thing. He worked on Singapore and many things, and joined here with me in computer science. Okay, so this is all my group and my institutes. Now I go to that research part. Okay, so that first four joint project things. Okay, that's first thing is that's my PhD, PhD, and all my doing alone, not with any groups, because I submitted in one project, but I unfortunately rejected, but waiting for other research also. That's mostly on mathematics, logic perspective of how the belief. Second project, most on cognitive science, working with the doctors, how the EEG, like a brain signal, how to do it. Because if see all this, my topic based on AI. Okay, we are writing some programs, analyzing and doing stuff, because currently, so that VEG, like VEG means visual, like visuality for EEG, like a brain signal, electrogram signals, taking how to synthesis, how to get some sort of good results. And we are applied again DPT research. And third thing is COVID, society, and then this bioscience. And finally, there's one more project for DRDO. It's not my project, but my friend project. They started together some collaboration for how to securing networking medical devices. That's based on blockchain. That's plenty of things. I'll explain one by one, don't worry. So we have a time, because we have 1 hour 30 minutes time. So I just elaborate my research, and we can stop anytime if you need doubts. Yeah. And you can see that this is my project. Basically, that you see that there's 4 different things working with my project things. But if you come to that next level, it's my students. Okay. So first thing is predicting anatomy center, because my Ramesh is that he's just started, just finished coursework and just started this research on predicting data center anatomy, basically security things, network thing, traffic signals. And second thing is my friend Rajesh is currently joined here. He started this research on water body management problem in IoT, and he just started my project. Research topics. And third thing is my friend, but it's not well, but he working on meditation emotional thing for like a brain signal. So that's it's not anymore to work, but anyway, this project is still going on good directions. And fourth thing is the brain tumor, how to analyze the brain tumor in machine learning, like especially deep learning techniques. So you can see that there's 8 different topic. One based on that my project level, and because we are different scenario, because especially in I like European style, because especially I did PhD in Germany, so I like this style, because guide do independent work, but student do independent work, so we can discuss. Okay, that's tricky, because of student can do whatever they want, guide do whatever they want, and if you have time we can discuss it. So that's a good deal, because I took this from German, from Hagen's style. So same thing I just follow in VIT also. Okay, so we'll go one by one to explain that bit scenario. And if you have questions, doubts, and then because I'm selling second part, tumor classification, I have a purpose. First thing, I'm going to start, my friend. So I'll give you a overall picture what things. Like first of all, I'll start with because of some image, and to boost the people's audience, because when I speaking in theory, mostly people symbols, mostly people are sometimes vague. Okay, what I'm talking about. When I give you some pictures, people are happy. That's why I just give some picture to starting explanation very easily. So this is a Rajesh work. The Rajesh start, because this slide from Rajesh, I just click to Rajesh only. So they Rajesh talking about going to start with the water body management with IoT things. Why need it? Because of that currently, because especially in India, don't talk about Russia, because of Russia is a big country. If you go from one place to other place, most of space is empty. But in India, it's especially if you go to that the region in Mumbai, Bangalore, or you can go to Chennai, it's mostly is mess, that even water, we can say that near the water body, they can put it, there's stuck to the pull, that they want to build a house and then do it. So that's why there's a very interesting problem. So what is urbanization is inevitable because of, we can make a good visualization for the people that do it. And then how the percentage of urbanized population is expected to increase more than significantly developed because of this and that. You can see that the picture in urbanized population, the world, see the number of things, 2020, 56%, maybe you can say 60, 50, it's maybe going more. In India, so India is again, 50%, 15% is more, means totally collapse in this the region, almost a region. Okay, so that's the reason that we can go for choose the problem, work on that based on that image and find out that exactly where this region is messed up, and then we just give this alarm to the government and then they can process. So basically this rapid urbanization.
Please continue.
Yeah, the urbanization needs to be more like sustainable, because that's the main thing you can do it in the scenario. The main thing is water body management. That's a, see, urbanization comes from ecosystems, different perspective, not only that the land acquisition, but even this water body, because the main thing is because sometimes it's rain, sometimes not raining in my place. Suppose not raining, the people will build the places, that sometimes the water body is vacant because no people, you can't find it, people there to stay. So that's the thing. So we were finding water body management, that's a very, very good thing. The scenario is the Rajesh from Bangalore, he took the example from Bangalore things, Bangalore water body things, what the thing is happen in current scenario. In 1960s, you can see that in the number of lakes in Bangalore, 1960. Okay, so number of huge number, but you can see the 2014, it's 210 lakes only there. Because see that the 2010 to 920. So you can see you cannot even calculate between the two regions, because too much region was occupied already. So that means and one few was good in states, because you can say that if you won 2014, currently now 2022, I don't know how many again gone. We don't know exactly that. Okay, what's question, please?
Well, basically, what is good state? Do you mean drinkable water or technical water or agricultural water? What is good state? The major concern: drinkable water or agricultural water?
I think Rajesh mentioned that the water should be common, like storage. Not because if you make a storage water, maybe you can use for drinking, you can do for farming, everything. So we are looking only for water places. So I'll give you some picture, maybe you understand. So this is a simple lake. We are not classifying that drinking water, or we can classify for that. I guess so, because Rajesh, maybe can you do something? Rajesh, are you here?
Yeah, I'm just unmuted.
Yeah.
Sorry.
I think
So the scenario, can you hear me, sir?
Yeah.
Yes.
So the scenario here we're talking is about a city in Bangalore, city called Bangalore, which is in state Karnataka in India. Okay, and it is a semi-arid area in the sense it does not have a river water resources in terms of a river. The city depends on the rainwater precipitation that falls on that area, right? So all that precipitation is supposed to go into the water bodies, the lakes essentially. Of the 210 water bodies that are identified in 2014, a very handful of them, maybe around 10 to 11, or in a healthy state. The degeneration, like water body degeneration, is happening due to happens of roads or residential complexes, all this kind of stuff. There is a severe stress on the landscape, and the catchment for the water body is having a big city itself depends on the lakes because of a lack of a river system nearby. It depends on the lakes for daily consumption, including drinking water. So the situation is not specific to Bengaluru alone, but it's pretty common in a lot of cities in India and also in a lot of other cities in semi-arid areas. All right. Does it answer the question?
Just to count lakes or reservoirs does not matter too much. Instead of small artificial lakes, something like this. So maybe big reservoirs is, for example, like Volga River is basically chain of reservoirs. So, and instead of small lakes, maybe it makes sense. So just count number of lakes, reservoirs, is not very important. Is not very important. It looks impressive, but not very important.
Point taken, sir. Yeah, point taken. So some of the lakes depends on the number of lakes and the quality of the lakes. Some of the lakes are pretty big, and it addresses a large segment of it. So maybe I need to make it a little more subjective in a sense. Point taken.
Okay, please continue, because basically you point out a problem, and at least
So the main thing is here we are see that there's some graph is there, because of based on that you can see above the average rainfall last 2 years. You can say that how much rainfall based on, because we are looking depends upon the rainfall. Okay, suppose you say that lake is gone, then how will you store this water? That's a problem. If you urbanize everything, this water bodies, then the problem for storage water is a problem, big problem. Okay, so that's see that the lakes. See, currently the lake look like a lake is there is no water, but the people will build the building, so that means that everything is gone. Where is a place to store the water? Okay, so that's especially this Kotegere is from town nearby the Belur. Okay, so how to do it? How to solve this problem? Because that's issues. Okay, so how to solve? Based on that, because based on that smart water management systems, is going to deal with this smart device, smart solution, smart service. Based on that, take a image and take a solutions based on this area things, and you can just mix with some big data analytics, some things you can find out that which is a good thing to give this society, and then they can make it for this solution for it. Okay, so that's smart water management is carried for two things: one for integrated water resource management, and then smart water grid distribution, because you can say distribute the water between this place to place, and not only that secure this water places, and we can how to distribute the water from among them also, based on that IoT with the machine learning perspective. So they do some analysis here. Actually, this is starting project. So how this based on that the three different perspective, one for hydro information and digital water and analytics. So based on that, you can say that based on that you can see what's the same, how much volume, how much data, that means flow data, and based on the what are the things happen, and based on that you can just do it. Okay, you can do that digital things like earth observation. You can say that take an image. So you can say that imaging, like take an image from drone systems based on the image analysis, and take the pictures between current pictures and old picture and compare it, and then use it for things. And you can say land uses like a transport network, utility networks, and you can do for other things also. And an hydro model, because that's a different model, because you can find out that the things what's changing and what other things happened. And 1 second, because my window. Okay. Yeah. So actually, what to do? The main thing is how to do analytics based on the actual data, pre-data, because actual data is currently the sense like in the from the sensor. You can find the things, and pre-data means hydro model, because you will find this prediction based on the machine learning can apply here to predict this. Maybe today how much, maybe next year how much we can predict something, and you can find this best case. What is if data is more and less, and then you can find a solution for it. So what is challenging it? Because this look like a simple, but what really big challenges. What are challenges here? Simply that dynamic nature, urban water management. I think because of that big challenging for the nature and sensitive to deliver all things to put together in this organization. And then the key contribution is simple that main thing is here accuracy, because whenever you can working on that how to predict this value and better value, how to move together and forward. Okay, so this is one of this point, and then you can just based on results you can say that to give the society to problem. But what is the need for this? What is the goal of this problem? So the monitoring this status of the water bodies and identify the problem for what is the catchment of water bodies, and access the importance of the proposed land use of changes, how they're changing the land use, and identify the solution for the current problem and potential problem for due to the proposed land use of challenges. Because based on that, this scenario, we want to find the achievement of this problems. So objectives, the clear objective is simple: high accuracies and high adaptation. This is very important. Based on that urbanization, and we can use different techniques on IoT use, or you can use for runoff model, because they are different models, but they are doing for different model to find out this clear cut picture and solve this goal. That's the thing. Okay. Yeah.
As an offense, at least I learned a new word from a catchment. I did not know it before. Водосбор. Thank you very much. At least sounds to me. Please continue.
No, it's not me. You can read, go to Rajesh, because Rajesh slide I took from the Rajesh slide. Okay, so these things. Okay, so you can see that goal, because Rajesh will expand going to do this kind of problem based on that. First of all, architecture problem for PWM, like PCS water, urban water model management, and then what is the ML based, how to do for ITO, because based on the ML based things, and developing that adaptation, new techniques for digitalization for like urban water management catchment, using for deep learning techniques. So this is all we want to solve these problems. And fourth thing is IoT based management, IoT based on that to solve the problem. And finally, you can go for hydro analytical things. So that's the main thing.
Could you please move to the previous slide? When we speak about, for example, digital Earth model, for example,
yes,
the third item. But now very popular word is digital twin. Is it a kind of digital twin? What is kind of model? What kind of models do you speak?
No, see, generally, you can take a model, because if you take a model for a drone things are catching, like a sensing rigs, like a model for the earth thing, So take that earth part, and the part because digital earth model means what? You take a picture of this scenario, okay, like catching that some places, like you can go to that 60s, 1960s, how it, 1970s, how it currently how it is based on that capturing this imaging from this earth. Okay.
Okay, please continue.
Please understand or not?
Well, basically, my question is digital twin, but digital twin is a very vague term. Because of this, I would like to know how precise, how accurate, what type of models do you use?
I think that this is a very accurate term, but it doesn't have numbers. It says that it's a mathematical model with a very high precision.
Well, people use it very different, but in principle, yes, in the extreme point, it is exactly a mathematical model. True. So.
Yeah, Rajesh, can you give some input?
If I just let me rephrase what I understood on the question.
No.
We are talking about the phase part 3. How do we digitize the urban catchment, right? Right, sir? Is that the question, sir?
No. The question is, say, digital earth model. You say that digital twin. You remember the digital twin? There is an uncertain model. So
we can kind of model. different, with, for example, it can be even differential equations with boundary conditions or something like this. It can be statistical model without differential equations at all. It can be only, let me say, well, some fuzzy logic model. For example, if
Yes, sir.
rainfall is in this range, then well, catchment can collect approximately this like this. So it can be very different. And again, model validation is very actual and very serious, important question in this case. But please continue. Maybe we'll explain later.
Yes. Okay. So
Yes, sir. I got the question.
maybe connection problem. Okay, Rajesh. We'll talk later because of.
Okay, we will have time to discuss. By the way, later.
So yeah, these kind of problems. So there are five different problems, and then you can get a results on five different problems. Results basically that based on the architecture, we find the architecture and ML based to find the solution for hydro model, and that especially that deep learning digital catchment is one thing, and then the fourth one is IoT based things give the give the problem, and finally you can say, because it is a five different problem, because finally you can say based on analytical system for hydro things. Okay, so this is a thing, but this is a again starting point. Even Rajesh also starting point. So they keep this result, maybe in future can be, it will come. So this is there is no any, you have already some couple of good results, but this kind of problem maybe it will be take some time to find, because this is a one of the area working. Okay. Yeah, so we can discuss something more on digital things maybe later on, maybe with my friend. Okay. And the second thing we can go for now, the interesting part in deep learning is tumor classification. That's we got a good results in tumor classification, but the main thing is we need some good evidence that to solve this problem, but we are doing that now. So first thing is, why we are doing, the main thing is medical image, like clinical information of diagnosis. Basically that we find this, if you go to the medical doctor to making with AI things to help to find this diagnosis, because that's the main thing. And the futures of in the current systems more, because you can say that not only in generally for brain tumor, if you go to accessing for the machine learning can more prominent results applying for in the current scenario for medical systems. Okay, why? Because of patient healthcare early detection, because of they can predict exactly what in especially COVID, that there's one more predictions there, and diagnosis and prevention, and make a treatment based on that. You can make it for this things, and various image modularity is various things here, and we take only one for histological image, because it's a like a image cut, based on this brain tumor, can cut the image. We can show what is the histological image, and then how you deal with to make a tissues prediction, and we can go how they're doing. I'll show you some. Here we are taking a MRI scan image, the brain image, and we can make it image to give this deep learning, and we can predict it. So it's like the main issue here is taking image problem, because image I need to take a doctor and find out that because always you download from UCL other thing, but we are already connected with the CMC at near my institutes, so they agree to give, and but the problem is more patient, because patient secret problems you cannot give, but anyway they want to do it some sort of things. Okay?
Excuse me, since it is not my domain, what are image modalities? What are image modalities?
So what are different models to find it? Okay, if you see that if you give one image, what are different categorization? Okay, because of when I give an image, how to take which part you want to take analysis, and which is exact which part, because I say that here I'll give this image here. Okay, so how to find this image, because the thing is, this is one cancer patient tissues image. How directly this image can take it out? image modality, because based on exactly which location you need to find out and where exactly to find it and how to extract this image. Okay, so that's the thing. Okay, so
Question,
yeah,
what's the proposed application? I understand that if you speak about tumors, most probably speak about which kind of tumors? It's
brain tumors.
So it's like volumetric images.
Yes.
Yeah, it means that there is some very expensive equipment.
Yes.
There are medical doctors who are doing this thing. So where in the pipeline of the screening your algorithm appears? What problems does it solve?
No, this is a good question, because I said that the image currently we are downloaded from you can say some download from the UCLA or other platform, because of the problem is you already the image should be taking is very tough because of, so we already some image already available in platform. We just only taking the image, and you see that now you're taking image, and I can say that I can show you that how are you doing. Take image, we can classify it. Okay, I'll back to your question. So this is how you doing these classifications. I'll back to you.
So you address the cases where the doctor cannot visually detect.
Yes, that's the main thing. That's a good thing. I'll back to this. Yeah, let's take this based on the simple image. How are you predicting that?
Image modality. Sorry, I still curious about image modality. I just search internet what is it and ask what is the Russian for. Okay,
I'll give you if you want
okay.
offline.
Please continue.
Okay, so why is it interesting for astrological image? No, because of you can't visualize directly, because you need something more on equipment, because you can buy some equipment should be expensive too much. But if you
how can you train the model without ground truth? Because if a human can detect, who will mark up?
That's why CNN. I just make it a different.
Yeah, so to train the model,
Yes,
there should be like a ground truth. And if a human cannot detect the thing, then how do you build the ground truth?
Yeah,
if human can detect the thing, then why do you need the model?
Yes. See, human. I say human cannot detect. That's the point. So human cannot detect predictions. That's why in machine learning can predict it. But see, you can take a simple example. Simple example is COVID. How you predict? How you prediction? Because of prediction, human predict. Because you can't human, because human predicts something, but you can go to that statistics methods. You can apply that method and get some prediction in early, because that's why. Because currently the COVID increasing, but no, not closing for anywhere in the borders. Why? Because of death cases less, and then there are plenty of things, casual things. The prediction should be good. That's why they open all the gates to come to anywhere to anywhere. Okay, the prediction human predicts something, but something machine learning predicts better than that human. That's the thing, better than human predicting. So that I don't want to go to more detail on what is the brain tumor classification. There are different classification techniques. So we are looking for one more thing, because of you can see that now how you're doing the tissues. So whatever this is a main thing, like we can say that there are many different cases like abnormal, normal. What exactly we want to be looking, because of I say already. So we are looking for not human detection, because we can go for machine learning, and like a gloma. The glosoma is a main thing, because you can't predict in human things. So the machine can predict exactly that how exactly prediction for how fast the tumor can be spread in the brain very quickly. Okay, their level is there. So see that level, WHO saying that low level, third level, and fourth level. Okay, so you can see the fourth level. Even the fourth level doctor cannot predict, but the machine learning can predict easily that. So this is a simple technique, because like medical terms, like how this brain tumor identification, because of you can see that nucleus and nucleo and axonus and different like neurons things. Okay, based on that exactly that the brain tumor identification, exactly that inner part of the nucleus. That's you can go to a inner depth of image. Okay, So how to do it? Because this is a problem, we can give you a slug image, and then you can say that the classification that you want to predict this is brain tumors, and how to do it. So that's the thing. We can go for using for deep learning technique, because it is already said that human cannot predict, but we can say that a machine can predict. Okay, so that's the thing. So basically, that deep learning classifications we use for ANN, CNN, RNN. There are many techniques currently. Things because we're using for RNN technique for predicting this image. Okay, so again, this is a simple. I say that already. The especially cancerous tumor features are very hard to detect. Okay, to finding the fourth level prediction is very hard to find because in deep learning, especially like a method for RCN, is predicting very fast and good results coming. Okay, and especially for you can say that you cannot predict with the microscopy because it is nano tissue, very small tissues. Okay, so the small tissues to predicting is the challenging one for the current scenario. Okay, and especially that the predicting is is come to that in the picture. It's very fast and curious to do it. Okay, and the main thing is what is the prediction here to reduce this pathological time, because if you go to pathological department, they take a lot of time to predict. Okay, but if we use this machine learning, it's giving the matter. So the tissues problem, you can just do here this part, and then just give a simple. Okay, so yeah, still because the people working on, we are also working on. And again, these are the more challenging here is whatever asking the same question, simple because of this complex problem. Okay, the main complex because how to predicting this real time. It's a tricky one and time consuming because of you can say make a not only one diagram. You can say millions, billions diagram to put trains models and test a model because test accuracy is very important. Because you can take a many image to make a train and test it and keep going on. This results still plenty of time. Okay, and the main thing is currently we got a lack accuracy because of why the image part, because that getting image part is tough in the current scenario because of one, especially for the instrument. Second thing is you cannot do that as a society. That's the thing. Still we are working on it.
Probably lack of data.
Yeah, because I said
let me. I'm confused.
Because
X-ray.
No, it is not
story
X-ray.
is very.
You can say this of any data. Now you can say that it's not.
You are talking about
Histology.
yes, because data is
story. Histology we have histology.
No, I'm talking about brain. Yeah, no, you cannot get it, but you can get it from online. Some sort of images less because less quantity, not
So probably mean that there is no public data.
no public. But it's there in especially CMC, my nearby institute, because they have it, but they can't give you data because of how. That's a research. See, that's a problem in research community with the medical doctor, because medical doctor have some sort of rules they follow. They cannot give
You
patients.
see that I posted in our Telegram chat. I didn't tell you that the Utrecht University is proposing to change the criteria of promotion assessment of the faculty from H index impact factor to a number of other commitments, including commitment to open science and open data.
Oh, that's good.
Meaning that the more they publish the data and so on, the more somehow is a proposal, but it's an idea to move from purely quantitative, measurable, what people measure, blah, blah, to some behavior. So you reward the behavior, no?
Yeah.
By the way, maybe it is time to have a break.
No, I'll take care.
Yeah, please.
I'll finish it.
When it will be more convenient for you.
Yeah. Maybe if it's coming like this in future, open to all, that's easy to do it.
Share with you the tweet that I
Sure.
posted.
Yeah. So what are the objective here? That you want to make a tumor classifications and based on the color, shape, size, and the better accuracy is the CNN. We just find out one results. and based on that, we can find this more. So the thing is here, see that image here, based on the image, you can find out that different classifications, and we get it. How do it? You can see the step by steps, because that's a very important steps you follow. So take an image acquisition, pre-processing, and detect the segmentations and feature extraction and feature selections and image classification. So you can see that take an image and do all the steps together, and based on that, what are steps you will find it. And you can say once image classification, we go for again based on the image, we want to find the image on nano size. So we can go to the again nano size, and we can go for augmentations. And based on that, now we are applying that augmentation to that deep learning technique. And once you're applying deep learning technique for CNN, we get the application for brain tumor things. Okay, so these steps you need to follow. So you can take this, not only the image taking, you can see that these steps you can follow, you get an achievement of to get this exactly, you can attack the problem. Okay, this is for one image. Okay, so maybe you can say that different problem, different techniques, but these techniques come from almost 5 plus 6 plus 4, 10 steps you can follow and get the results for to detecting this image things. Okay, so I give one example here, CNN. So I'm not go much deeper because of yeah. So how you do for CNN? Say we can say that already input layer, and based on the hidden layers, and give output layer based on this simple scenario, and do this based on the same thing, like it's like an image, and give the feature extraction and find this path where exactly that being between this, which line you are doing, like based on that feature extraction, because we say that good and bad cells, and then you can find out this results. Okay, based on that techniques back, because we apply some mathematical technique to find out that the back propagations, especially here, this part. And this is the process. Give an image and CNN doing, and based on this classification will come from. So what is the CNN doing? Based on that, the kernel and the different two kernels, and how much weightage things, and we can make a back propagation. Because why back propagation? Because why we are doing for nano size. So you can go check whether this exactly that tissues is correct, and then you can just say that okay, the classification is good. You can say that because whatever prediction is good, then you can stop this image. Okay, my publications, there are quite a number of good publications in this scenario. Okay.
So break.
Yes.
So break for a while. I would like to stop recording. In 5 minutes, I hope we will be back. People can chat if they would like. In particular, if Delhibabu would like to stay here, you can ask him questions. But I would like to go cup of coffee.
Okay. So we are still 3 more to go, but I don't know how much we'll finish today, but we'll go for next one is cognitive science, very interesting for me. So we just give a flavor because of I want to cover other topics. So first thing is we can go for the main thing is automated televideo EEG, because like a electroencephalogram, like a brain waves to how to do automated, like that's a interesting one, because why? Because especially electrogram is a vital for making a diagnosis for treatment of epilepsy is one of the diagnoses for neuro things. So how to do it? Because currently available EEG machines very expensive, and then less because if you want to EEG, because suppose you have a blood test, you can go to the nearest hospital, like a center, take a blood and do it analysis. But if you want to do it in EEG, you can go to hospital only. My scenario, because we are going for things, we can build a new EEG as well as we can make it for based on AI applications. We can reduce this things in fast manner. Okay, so the main thing is here because of lack of diagnosis, lack of access for like devices, and you can go to the even if you're a town, you can go to hospital. Suppose you are in a semi-urban or rural area, and there may be a poor access for the machines, and because main thing is to reduce this treatment gap between like people for how to do it in very fast manner to make it because of one more thing is the device is less device. Second thing is neurologist. If India you take a neurologist means a neurology neurosurgeon, so one in hospital. So in one big hospital, maybe 1 or 2 seats. It's very less people in neurologists. Okay, that's a demanding field as well as less number of persons working in neurologists. Okay, so what's the objective here? To like make a developing automated, that's the main thing, automated tele-EEG, and you can say safety things. Second thing is study for validity and safety, and we can take it granting from this CDSO because of Central Drug Standard Control Organization, get approved from this EEG machines to use for human things, and you can say manufacturing this EEG and get the feedback from this audience. So what is the thing? Easy to use, minimize the training and maintenance, because if you go to that blood center, they easily no need to do doctors, because in nurse, if you nurse, they can take it take a blood and analysis, you give results. Same thing if you want to do it EEG, especially the brain signal, they are making some specialist can be doing to do it. But our point is why you want to do special people. We can make it a comfortable. Okay, just make it put it in the box. Actually, I have easily how to do it is very easy manner. That's one thing, and without no train, because even this suppose if you're working on EEG, you want to fix this based on the 8 channel, 18 channel, you want to fix this. So you give one cap. You can input anything. So you put a cap directly, and we can directly you can just find its location easily, and then these devices. Okay, and passion-free, pain-free. That's the thing. Again, one thing is everything digital things, because you can take all EEG signal. Simple manner, and it's a simple AI technique can follow, and is a cost effective. So I'll see that I can show you some. What are the simple example is this is a brain model. So if you want to put it in this 8 or 18 channel, we can put it in the exact locations. That's important. But in our device, you don't want to take the. We can just do it in this rectangle manner. Okay, so maybe I figure, yeah. Say like that, but it's not like that. This is not our things, but similar to that. Okay, so similar to that, you can put it and take this, take the data to that cloud, and doctor will see that you can doctor sit anywhere in the world. Especially, I can tell you one example. What is nearest country in Russia? Belarus. Belarus.
Ukraine.
No, US. I know US is big.
Also Japan.
Yeah. Yeah.
Kazakhstan.
Yes. I can do Belarus. No. I don't want to go other, because currently that doctor I told now, because Nadesan from neurosurgeon, he working on Belarus, but he's sitting in India. He working in Belarus because of all data to the cloud. And he's sitting in somewhere in this in the world, he could predict it. So that's a main advantage here. How to do it? We can say that put it in this EEG signal. You can say EEG signal and pre-processing, and based on the CNN classification and extraction, and based on classification from ANN, and predicting the trends. Currently, the signal is good or bad, and once auto validation, because based on this AI can apply here. If it fail means again you can repeat this process, because the signal, we can 80 channel based on that, because mostly the all over the world using for 80 channel, okay, not more than that. But in research we are working 250 channel also, because of but in doc. So then if you want success in AI, then centralized report process, because the centralized thing is the cloud, to store the places. After store, this thing is, because especially that doctor from currently in Belarus working, because Belarus they store it in cloud, and you can say that based on that store, we can say like a epidemiology, because that the doctor can take a login and view this EEG with the AI help of EEG. And there are two processes, one for reinforcement learning, and second thing, exactly what service you needed, and they give a treatment from telemedicine. Because of doctor sitting one place, patient sitting another place, you can you can just exchange your ideas and working on this. I think it's a big project, and the world also working on the same. And yeah, because of why is interesting this field, because of nowadays many people getting tension, like a neurological problem, especially Europeans. Getting a lot of effects. That's why we are going to move on to that cloud things in AI, and we can go achieve very quickly and nice things. Okay, and so this is a thing. This is a problem. What is the solution? So I already said that based on the error free, because we make machines clearly we can give you. So because the machine is, I think we build own machines. So based on that, we can use it. You can take your own, because you can order in Amazon, whatever I can say in future. Take it and put it in inside and do whatever you want, and then we can put it in. You can sleep, what you can play, whatever. I can put it in myself. That's the thing. Okay, this is things, and basically it's a plug and play. So that's a telemedicine, because just do whatever. Because we just say that first we can plug it, and we can tell you what's the problem you have, and then we can solve it. That's the thing. If the success project, and you can say reducing epidemiology treatment gap between less than 20, because you know that we can make it a reduces, especially epidemiologists, and then you can say that and more number of diagnoses, not only for, so the important thing is neurology thing is the heart attack. You know, the people getting heart attack in night time. So still people doesn't know why. Based on that, because you know, if you these devices can be used, maybe we can predict. Because of sleeping, while sleeping we can predict it, because of you can make alarm, and then we can check whether you are
So
yeah.
what these numbers are? Percentage?
Yes, percentage. Yeah, sorry, I put percentage.
Yes, because
Yes.
well,
It's percentage. I miss
I
it.
think it's because you combine Atlantic without
Yes. It's just slash. That's the problem.
without the
Yes, it's a correct point. Percentage. Yes.
but it's good. You managed to compile it. Tell you.
Yeah.
It's a comment. It's a comment.
Per person number.
No, we can put it.
right.
No, you put dollar. You can put dollar,
I
and
thought it was-
yeah. I forget. Last minute I prepared it. And then, yeah. So yeah, that's the main thing is I say that the machine is for us, because that's the
A question.
Yeah.
Just a slide before, or a couple of slides before, when you spoke about product. Like, no, back. Forward.
Yeah.
Next slide, please. 44. Well, and maybe next.
No, tell me a question. I understand.
Okay. Brilliant, splendid views, but timeline.
Yes, this is a
When
big
do
project.
you promise?
This is a big project. No, this is a big project. See that you can check this, especially in.
If in 50 years.
No, not 50 years. No. See, I tell you one thing. The current scenario, I cannot open this thing, because my friend working in the same project in what is the name? England. What is the next small country? Ireland. Ireland people. Ireland, what people working?
I call Scotland.
Yeah,
So it will be the country.
Island people.
For football is a country. No, it's a different thing.
Small cut. Okay, Ireland people are working the same problem. Okay, but not still solid. But we got some results already, some wins. Yeah.
It's a better thing to be a small island next to India. No one can remember.
Any more questions? Any more? Because this is all working model. I'm just saying, I'm not going for deeper. Yeah, and the next problem is accounting is very interesting problem for because you do meditation. Okay, this is a simple view how emotional things can be captured in AI. So that's a nice things. Okay, so the main thing is here how do the neural noise. Neural noise means so in generally that when you're doing meditation, alpha, beta, gamma, theta, delta. So there are 4 different waves in the brain. Okay, so you say that in the scientific community, when you do alpha waves is more, then you do meditated. Okay, so that's a pretty trend long back. But recently, they're saying that no, beta waves should be there. So that's the thing, that we are still their meditation is one of the good goal because of I'm from India. India is especially meditation is number one, not number one because of relax. So the meditation is there. So we are going to that. Like there are two noise, one for inner and outer. Maybe missions, like outer based on the missions problem or based on those other separate things. But inner noise come from based on your whole genetic, because maybe the problem for your body based on the noise can reduce. So the noise reduction is very impact because of, especially we are working on this EEG noise reduction, because that's a again one more challenging one. How do the noise thing is to reduce and get the results clear? Because still the current world, people checking with the diagnosing with the EEG, looking at the paper. Okay, they if I have problem one day my EEG and take the printout and doing each and every page is looking doctors, because still people are working because they're not going for this AI based. But is my problem is successful, maybe it reduces the number of pages, because one much pages doctor will do it. Maybe the errors will be coming because no doctor not always concentrate to checking all the waves, no, because of maybe sometime it be problematic also. So we are doing so the same scenario here also. We are looking for the information between this neural patterns, firing this neural patterns, because there are two things I say that based on that for meditations, alpha beta waves now firing doctor. Okay, so what is the objectives? Why we are doing this very interesting one? Because of main thing is the brain computer interface. Based on that, how we are doing for the brain computer to it missions, and then the various meditation, because you know that meditation not only the one type, because of different types, because we want to find this the how this brain sparking is scenario. Okay, so there are different types. You can go different types like hatha yoga, karma yoga, different types there, and then we collect all the types and find out that which is the correct waves, and we can spiral the brain things, rhythmic meditations. Okay, and understanding that the role of different meditation practices and different memories, emotions, because if you go to that Thailand and monks, they have a emotionally they were controlled very much. We want to predict how they are doing. So these are our because the people are working now, and main thing is how to towards this neural correlation. So the main thing is the noise reduction, making for the meditation research. So how to do it? So based on that, we can take it group, split the group, and each group of 30, 30, 30, 30, and you can see that the different, that 1, 2, 3, 4, 5 groups. So because why the 5 group? Because of the 5 major groups in you take any meditations. Okay, so there's 5 groups. You make a 30 volunteers, so 150 volunteers. You find 30 volunteers. You can find this problem. We can say same thing EEG recording, and you can say that functional NIR recordings, both things fMRI, NIR, fMRI, EEG put together and find this where exactly the neurosparking, and we can find out this. This is a good caution for this also. Okay, this is the main thing. The projects there in working on especially IIT. So you know that IIT people.
No, we've done a study on not exactly like this, but kind of. By Vitali, one of my students now graduated. Basically, we try to or reject the claim according to which meditation helps programming, which I think it does. But in the setting that we experimented, it doesn't. Because basically we ask the students, mostly some programming from very small sample people, to do a meditation session, this yoga session, instead of 15 minutes, blah, blah, blah.
Taking EEG?
Yeah, no, without the EEG. The EEG was put after, during the programming session. And then it was done the same without the meditation session to see the patterns.
Okay.
And the result is that, but this is, I think is kind of obvious that the result is that in this specific setting, the meditation doesn't help the problem.
Oh.
Because I don't think the meditation is not a better problem. You know? Problem is a very rational action, no? And but numerically, basically, experimentally, it shows that it doesn't help. Because problem meditation is something that you need to do every day, regularly, for a state of mind that is suitable for work, but not that you have to do it before the programming session. I don't think it helps, no? Even doing meditation probably immediately before the race, the game, football game or biking race wouldn't probably help either. However, for example, the racer, the bikers, they do kind of meditation exactly before the race, but I don't think it is kind of meditation. For example, Valentino Rossi spends now with the time, what you know, not the biker. He was spending 40 minutes before every race along with the bicycle, with the motorbike. You know? But I don't think he was doing this kind of meditation, because this meditation is about changing the waves pattern of the brain. He's probably just working with imagination about the race. But basically, yes, what we discovered, however, the sample of people was very small, was 8 or 10 people. That if you do the meditation immediately before the programming session, it doesn't work.
Oh.
That's it.
Okay.
I think it's logical, no? Because it's not drinking a glass of water that at first they drink. Is a practice that has to be done on a regular basis to have a state of mind that is overall balanced. Just to tell you what we.
But our prediction is based on that. What's the goal of our prediction is where emotional can come. Emotionally, how because of we see that which meditation is less emotional, more emotional. We want to classify it. So that's the thing. Yeah, maybe your case is not saying, but you know that the Apple died, you know, that Steve Jobs. You say that you do always when because of.
I do this regularly. No?
Yes.
You cannot say if you've never been done meditation before in your session now, it's very unlikely that the programming session that you do afterwards. But again, it was just a little study.
Anyway, yeah. So I just go for next one. I just skip one more because of this is already.
Just an HR question for what Manuel did say. If so, in case if you find that meditation helps for programming, then it will be definitely publishable. If you find that well in your experiment it doesn't help, is it publishable?
We published, but in a kind of secondary context.
Basically, it is the kind of that we couldn't detect anything.
Yeah, true.
For example, we couldn't detect life on Mars.
The journal rejected the paper, but then we published it. It's true. Because, no, but we detect, of course, negative result is very difficult to publish, but to the top journals. But what is interesting in this article is that, in my opinion, no, if there is something that we really want to find interesting, is that it's not that straightforward. You know? Like meditation, and then you become a good program. It's not that straightforward because it's not like a pill, aspirin that you have. They can. No, it doesn't cure the symptom. The meditation it creates a lifestyle.
By the way, nevertheless, you are. Not at all. I'm not going to make it publicly at least. Well, you know, Ig Nobel Prize. Well, sometimes is given for awarded for very indeed research. For example, how any magnetic field. So well,
but since I
think
cannot
about
win
this.
Nobel Price, at least I will be able to be Ig Nobel.
Ig Nobel, it will promote university either.
Exactly.
Think about it. Please go.
By the way, animals of course are affected by the birds are affected by the.
Well, this is case where a Russian written book is better than any corresponding English book. since I have a very good Russian survey on a Nobel Prizes, regionally, once upon a time, I'm going to present some overview of this research. Maybe on occasion of April 1st or something like that.
Okay, maybe any audience have doubts? Maybe that's a good question because we are talking. Maybe some people.
Any questions from internet, from Zoomers and the rumors? We are rumors.
There are only two participants, like active
Actual participants.
You're fake news.
I'm participating twice.
Okay, anyway, we can go.
We have two colleagues of Delhibabu and one guy from Novosibirsk.
Okay, so I skip because of already this thing, the belief revision. No, I won't touch.
Okay.
Yeah, we can.
And basically, you should conclude in, let me say, in 10 minutes.
Okay.
And also, it will be very nice if we will have some discussion because I have two major questions, not technical but major.
Yeah, this is one main thing I can tell you that one start thing. Suppose this is if you're working in theoretically, it's easy because robot servicing, because I talk about in manual morning also, because service robots in Germany, in Aachen, they're working in more theoretical problems. Okay.
Discussion about the robot, the stuff that is robot, it's problem. You started, but you didn't. Okay,
so they are asking, see that here you can say the belief revision coming. So robot, because human asking red color coffee, but robot can go to that kitchen, it's a blue color coffee, but how the device, how the beliefs changing the robots and taking a blue cups. So they are working in real time and mathematically they are doing in more research on that. And second thing is sensing, that if the robot there at the wall, especially Robocop projects, they want to play robot and human with robots, 2050 Robocop projects. That's because of less time. So I go directly that main thing for security. That's very important. So first of all, there's a security network in medical devices. That's a main thing, because my friend is still here. He are working in this thing. Basically, that networking medical devices are aimed to be improving the quality of living, as well as living safe, life-saving the devices for the patients, and especially that they're going for the talking with via hospital, Ethernet or Wi-Fi, whatever with the things. And main thing is how to doing based on that medical devices and sent to that center, and you can do it. How they're doing? Please check this. See that networking medical devices based on that they have it and form and data gathering from these medical devices. And blockchain is a technology because of, you can say that, because there's because your security is there, you cannot say always all can work together. So you can say that getting verification and approval feedback. Once this approval feedback based on that data fusions and analytical based on that given the data, and you can give the feedback to that medical devices, and you can say emergency, you can just do it for the nearest hospital. You can go and help this patient. That's the thing. Simple. So here, the blockchain is a very important scenario to make it verification and approve for the feedbacks. That's the main thing. Okay. So what is the process? How is it working? The main thing is the patient collecting that data from the device and upstream the data from the server. And then you can see that the retrieving from the health system and applying the sensing data and making analytical things. Finally, that feedback to the health systems and approve the blockchain. Because of why approval? Because of the data should be correct. That's the thing. There's a give approval, and there's a successful medical device to give this data to that exact scenario. Okay, so this is a current trending for the world. Okay, people are working on blockchain. Okay. Any questions, doubts? Okay. Okay. So this is our process, and I skip for again because last 10 minutes. Again, security for petitioning for anonymity is simple. The network problems, and one of our students started this project problems and working for how this like especially Cisco, he's a director of Cisco. So he printing that anonymity in the Cisco center, the data center. Okay, so I just skip some more things because of times less permitted. So basically, what's the plan here? What are the application data center operations, and we can make a planning for exactly what kind of threats anonymity rating, and then read for all the things and get the good results for that to predict it. And the main thing is here there are two systems, one for distributed systems and hyper cloud. Okay, there are two things based on that applications. So, best to rating for anonymity for the given the scenario for it. Okay. So what is what are the cases you can say how the collecting data, how to study for identification for machine learning and applying the accuracy part, and you can say anonymity detections, main things, and forecasting for planning and reducing this optimization. So based on this kind of things. Is there's a meantime is repairing is very high to the environment, and you can say thing is and helping that planning things also, and helping for this operations part. Okay, so that's it. And challenging is very big challenges because of main thing is data come from the multi sources, and data is the structure and structure. So we don't know exactly which is data. And the folding is main thing, dynamic access folding, because endpoint, the main thing is endpoint folding thing is the important one. And we can find the boundary to and find this anonymity for things. Yeah, so yeah, these objectives, you can find the anonymity detections due to that because of misbehaving things and misconfiguration and some attacks, and maybe the detection working on hybrid clouds and planning and optimization, because there are different scenario to find the substitute for this point. Yeah, so the final things, because this is simple for security, because of see that security for medical devices and for security for the data centers, the two things. Okay, and finally the COVID. Okay, the society, that's very important. Okay, so why? Because we know that the people currently we are struggling in pandemic. How is the people so even I'm finding now, I take RTP test. So you can say RTP test take in now they make a chip. Okay, we can take maybe 10 seconds and few seconds. But again, if you take a RTP test, is maybe you can say coming results 2 or false. We don't know. Okay, and you can go to RTP test. You can take a 3 days, 2 days sometime, and you can take an X-ray, whatever. You take an X-ray, blood test, whatever. At least 6 hours or something. But we say that this is a new thing. Is not new. Like biomarkers, if you could say, I'll give you some picture. Suppose this is a machine, we apply this project and then we are waiting for this funding. So this machine from France. So you can say, we can just blow, you can just make a blow for this here, and they can analyze the biomarker. Based on the biomarker, they say that you are COVID or not COVID, not only COVID, even this whole body, you have a problem with. Okay, so it not only for this biofuel, not only for this COVID, but this is essential for all medical things. Okay, so especially for your any problem in the whole bodies. So basically, what the thing is here, we say and reducing this X-ray things fast enough, and we can say mass spectrometer to find out results for even ICU patients. Because ICU patients, we can very quickly we get the results, and then maybe say that the results come from within a seconds, maybe 5-3 seconds we can get the results for it with the help of the AI. Okay, so you can see this is a current project, and then the project was currently in India. Ambani, that. Geo is a very famous in our place. Ambani took this project actually that they have started. I think that the project was started from Israel, and then Israel machines Ambani took for the billion dollars took from India, but India is still not approving the project. So we are trying for this project very rapidly, but we are waiting for more than 8 months waiting for results. And you can see that the current trends, you can see current paper still people are publishing on, because we see that these are different biomarkers. based on different biomarkers, you can say that which diseases you can say that. Basically, the COVID, especially COVID, we have said that now you can say up I think is COVID. Okay, because other lines are not COVID, other diseases. Okay, easily you can. So, because I don't go much, because I don't know much thing here. I'm looking only for AI things. My friends working on more backend, doctors working in backend. Okay, so the results, I say that we have this whole project, because see that one more main thing is these all things started last 2 years before the pandemic time. So we are starting this all the projects, take some time. Currently we have a 5 journal and 3 conference. Currently this all we're talking about, and 4 different projects. We got 2 and we are opting for 2 more, waiting for results. Quickly results will come. And 2 labs, we already set up in lab in VIT in Congress and COVID lab in CMC hospital. So this is outcome for our results. Okay, so that's the thing for, I want to say that thanks for your valuable time. Thanks for talk. Any questions, doubts, you can discuss. Thank you.
Well, thank you very much for for your talk. Of course, the second part was in roughly speaking in high pace, but so basically, well, we are out of time. Nevertheless, thank you very much. So questions, please. Questions and comments.
A very general question. It's not about the content of the project, but it's about how do you manage to guide 4 projects? So how do you distribute the time?
No, because you know, I said the group, no?
But still, you are either a manager or
No, I'll tell you.
Hmm?
So I'll tell you because of take this project, especially he's on, because I'm working joint worker. He's one project head, he's other project head, he's other project. I have one project. So I'm working for, so because of, you can see that there are different problems, not only one problem.
But you contribute to all of them.
Yes. Contribute means
you switch the context of the
yes.
problem every time. So it's very hard.
Because you know, I told already now, because I like German technique. So faculty,
What do you like?
German techniques, because of Germans, especially
German.
yeah, Germans are working independent, faculty working independent, students working independent. Okay, so I working my area focused on students, because I said that the other 4 topics, especially you can see that these topics I'm not contributing anything, because it's all my student projects. Okay, so this is I'm contributing mostly these projects, and I'm only one first title. I'm head. Other things I'm not. Raising other people. I'm just contributing AI based one. So its time is there, and then we can contribute.
I mean, like having 4 projects do like driving in the 4 times slower speed. Is it better than doing one project at a full pace?
Exactly. Your first project is mine.
But you don't spend like 90% of the time to this project.
No, because this because last 3 thing is other people are managing. Okay, so I just giving one small part. You can say 5%, 10%, because he's doing driven because of
10% here, 10% here, 10% here. So
Maybe-
70 remains there, and also your students.
student work.
And also teaching maybe.
Yes, because
Sorry for speaking. Yes.
You're waking up every day at 4 for that, right?
yeah, because I sleeping very early. That's why.
Successful person, they say, waking up at 4.
So we are expecting
But there's
maybe
no one else waking up at 4.
Well. Neither Caesar nor Napoleon finished well.
Yeah.
But they are in the book.
And Berlusconi was not finished well either.
So
It's also in the book.
I also have a couple of general questions.
Mhm.
General questions. Of course, you had no time to present what did I believe revision or something like this.
I don't know.
But nevertheless,
I can talk.
it seems that, well, basically all artificial intelligence models that you are using, well, are not what can be called classic that was developed before neural networks.
Yes.
So does it mean that all this stuff like fuzziness, for example, or other kinds of other stuff I don't know right now is well absolutely useless and well not relevant.
If you ask this kind of question, I can give you a simple answer. No,
Make you. In particular, can you demonstrate a field where artificial intelligence still rely upon classical stuff?
Prof.
Yes, I understand. So I can give you a nice answer for you. So in physics, okay, do you know dark energy? You know dark energy? No,
I know term dark energy.
Exactly.
I don't know dark energy.
No, I'm telling.
Never seen it.
Huh?
I went to it. I never seen it.
See, whatever physics in the world people are working, dark energy is zero. Okay. So if you ask this same question here. So if you want touch dark energy, how to work with dark energy means everything, whatever the law, mass, energy, whatever, everything zero. So same thing. Whatever AI working as classical, non-classical things, if you talk about this one, there's no answer. Everything is, see, currently people say, well, I can tell you one thing. People now moving for AI. Why? Because of predictions. Good. One professor from Germany is from Uli Fabak. So he came to VIT. So he is a retired professor, is almost 70 plus. Okay. So he working on more on machine learning. He told me that, do you know that deep learning? Because still famous, but they cannot understand that how many layers hidden layer can use. Uncertain. Okay, still people doesn't know, because I'm showing the results. Okay. This feature extraction one go more deeper. So the hidden layer 1, hidden layer 2. My thing is I'm saying the 2 hidden layer. So some example, but in my problem, this computer can decide it automatically. Okay, so we cannot even control it. So our control is not there. Okay, so control from computer. Okay, so we give option to computer. Computer can take own decision, take number of layers, can take it. So same thing. So, but one thing I want, that Uli saying that the results you predicting correct or not. Yes, results are good. So that's enough. I'm happy. But I don't care about what the third process. Third process zero. We don't want care. So we order coffee. The coffee is coming. Okay, but we don't care about how the coffee is making, how the machine is doing. We don't care. But if you want to care these things, everything miss. This world, everything miss. That's why people moving for AI. Okay, I also move AI because I'm AI fan. That's why I'm saying we want some results. Okay, so I'm telling again. So we're going to sleep. Okay, tomorrow we wake up. Do you know that we wake up? How much percentage? So that means we wake up. So that means we have some results coming. That's very happy. So if you go inside to dicker, you don't get answer.
And that's my also.
Okay, my answer is okay.
Oh, it was an answer. It was an answer.
It was an answer. Maybe Manuel can
It's a
help.
kind of game. My move, your move. My move, your move. My next question is also quite general. Do you feel, let me say, that do you feel some deficit of, or maybe what is major software engineering problem in this field?
Major software?
Major software engineering problem in field of applications of artificial intelligence. What is the most major? Very general question, but formally speaking, I should ask this question because we are Russian software engineers.
Maybe.
Sorry.
I can say what's the problem.
Okay. By the way, next week we are going to have a public discussion. What may a few words in Russian? Что не в скобках. Не в скобках с вопросом. Не так в российской науке.
If you ask,
Понятно, не в скобках. Затем есть вопросы, потому что может быть так. Then we will be discussed.
Maybe I ask. No, I asked my friend to help because of the. Okay, and Bala will answer.
Not the major, maybe several major problems with software engineering in applications of artificial intelligence.
Bala, can you answer this question?
Because you are teaching practical and theoretical.
Wait. My friend Bala, can I answer the question?
Hello?
Yeah, the question you understand for you?
Yeah. No, can you please repeat the question?
Repeat the question. Please,
So what is the major problems with for software engineering in the field of applications of artificial intelligence to real life problems? Do you feel that software does not help? For example, software is not
Yeah, of course.
properly designed.
Docker will definitely help in different directions. Let's say then you can identify the bugs in the things. That's the first thing. And second thing, if you practice some of the things, then you can easily say, for example, if you want to do continuous development and continuous integration and continuous deployment, in that particular scenario also you can do that. The Dockers will be really helpful. And you can also verify the software dependabilities. So if you want to verify the software dependability, then also you can use that. And then nowadays, I saw some very advanced approaches there. They are trying to identify the software security into the Docker. So they want to assess the software security also. They want to know the status. Let's say, for example, the formal methods are mostly used in the, you can implement and then you can verify those things. Let's say, for example, if you develop a new software, that software is not at all come to a product line. So before that, you have to do a lot of tests. So during that period also, you can also verify those things. And apart from that, if you want to educate the student, and it's a very well environment wherein you can use software, you can use the Docker for practicing. Because I myself experienced this thing. This one I have used in one of my courses that I have handled, cloud microservices and applications. There I have used Dockers extensively. I asked the students to develop a lot of, and then I asked them to verify, use different kinds of software. Let's say, for example, Jenkins, if you want to use, and then if you want to use Ansible playbook. So in that particular scenario, they are experiencing. So from the student perspective, it is different. From the industry perspective, the Docker has its own advantages. And then for the software engineering, especially for software engineering, it is very, very helpful because it's modern day software engineering, mainly moving towards the agile development, so and then Scrum development. In that particular scenario, Dockers are the right choice for practicing those things. And one personal experience is that one that I already told you. The students extensively use the Docker, and I asked the students to develop the applications and continuous development. I asked them to post their source codes in the GitHub, and then if there is any continuous changing, I asked them intentionally to do the changes in their development software, and then it will fire the continuous integration, and then that in turn fires the continuous deployment that using Ansible. So they have extensively used it. Instead of using the cloud computing, I asked them extensively use the Docker, because if you know the process, and then I also educate them to use Docker, that is very lean Docker. Let's say, for example, if my application is in C, so it is not necessary to build a very, very huge virtual machine for that. Instead of virtual machine, I can go for a Docker. So it is very lean, let's say, or about 10 MB size. So with that, they can easily experience only that Docker will run only the C applications. So applications are plenty. The thing is that how are we using that? So to which domain we are going to apply, that plays a crucial role here. Did I answer your question?
Okay, let me be honest. Well, it is a kind of game, but since speaker his volume of speaker was quite low, I will listen your answer in full details later. But thank you very much. I hope that you answer. But let me listen. Did you understand me?
Sorry.
So basically, the volume of speaker here was quite low. And because of this, I don't understand full details of your answer. I will listen your answer again later. But thank you very much for your answer. I'll listen later.
Yeah.
This is true answer. True reply.
Yeah.
Replic from my side.
Yes.
Okay.
Yes.
So thank you very much.
What about any other question asked because of one people from Novosibirsk?
Evgeny, would you like to ask something?
No, I don't want to ask. Okay.
Very open answer. No, I don't want to ask. Very much for being with us. So let me thank everyone once again. Delhibabu for his talk, his colleagues for participation and contribution, all attendees for, in spite of late and short notice, coming for this seminar. Thank you very much, Stas. Bye.
Bye.